Hello, my dear students. Welcome back to my Sheetal's classes to my channel. So, I think you have followed the last class, that is the units and measurement part 2 and also part 1. So, now let us go to the last topic of this chapter, that is significant figures. So, here, if you study along with me, I will make you dhurandhar of physics. Yeah, so that is only the topic of this or title of this class, today's class. If you study with me, along with me, you will become the dhurandhar of the physics. It is my challenge. Okay, so let's get started. So, what is meant by significant figures? So, here, if you have a number like 0.234, right, 0.234 or 23.4, right? So, such numbers here, these all have a certain value, right? But in this, there are 23 is certain number and 4 is uncertain number. Either you can omit it or you can take it because it is less than 5. And here, all these are certain numbers, leaving the 0, right? So, in a significant figure, there are certain numbers and in uncertain numbers, or we can tell that reliable digits and non-reliable digits. Okay, and such totally those figures or numbers, number of figures is known as the significant figure. Okay, so here when we have to take this significant figure, how much for when the zeros will be taken as significant or insignificant, that we are going to study in detail, line by line. What I am telling this is your NCERT textbook. This is your NCERT textbook, physics textbook. Okay, that is part 1. I will read this line by line for you. I will read this book line by line for you so that you can understand it thoroughly, right? And no need of you to read it because I am reading for you, right? Okay, so here errors they have mentioned, as discussed above. Every measurement involves errors. So errors means what? It is the difference between the true value and the measured value. It is the, what is the error? Error is the difference between true value and measured value. For example, if you are doing a experiment on the acceleration to determine the acceleration due to gravity, all you know that everyone knows that what is the acceleration due to gravity value? G is equal to 9.8 meter per second square, right? But when you measure it, you get like 10.2, 10.3 and so on and so forth, or you may get 9.5. So here the error, how much, what you are getting by measuring doing the experiment is, true value is 9.8 minus, let us consider 9.5. so what you get, the answer 0.3 meter per second. This is the error. So that is known as the delta value. Okay, or delta G we can take, because we are going to find the error in the acceleration due to gravity. So that's why we are going to take it as delta G. Okay, understood? So here you see on the first sentence itself I have explained what is meant by error. No issue. So let us go to the next sentence. Thus the result of measured measurement should be reported in a way that it indicates the precision of the measurement. Therefore, what it is, how much precise the measured value is, that gives the error, how much error. So repeatedly if you do the experiment, you are coming closer and closer to the true value. That means the error will be decreased step by step for every experiment what you are doing, how many times you are taking the trials. Okay, now precision is what? It is the correct value, you are coming nearing to the true value, that is known as precision. Okay, by taking number of trials. Normally the reported value result of measurement is a number that includes all the digits in the number that are known reliably plus the first digit that is uncertain. Okay, so first will be certain, so this will be uncertain. So therefore, what is the definition for the significant figure? Let us see. The reliable digits plus the first uncertain digit are known as the significant digits or significant figures. So now I have told you 23.4. So this is 23.4. So this is the certain value and this is the uncertain value. So both together we will take it as 3. So how many significant figures are there? 3. Okay. So this, because all these 3 are the non-zero numbers, hence we will count the non-zero numbers and take the value. So when we have to consider zeros, when we should not consider the zeros, that we will be discussing here. If we say that the period of oscillation of the simple pendulum is 1.62 second, the digits 1 and 6 are reliable and certain, while the second digit 2 is uncertain. So here you see, after the decimal point we have 2 digits. So the first digit we will take it as certain, and also the 1, no problem, 1 we have to take it, but 2 it is uncertain. We can omit it because it is lesser than 5. But even then we will take it because it is not 0. Okay. So here again this 1.62 will be totally it will have. So you can see here. Thus the measured value has 3 significant figures. You got it? It has 3 significant figures. The length of an object reported after measurement to be 287.5 centimeter has 4 significance. So here this much it is 287.5 centimeter. So all totally how many significant figures? There are 4 significant figures. So 287 are certain value and 5 is the uncertain value. But even then we will consider 5 also as the significant. So sometimes what happens is, clearly reporting the result of measurement that includes more digits than the significant digits is superfluous. Superfluous means it is not needed. Okay. And also misleading, since it would give a wrong idea about the precision of the measurement. So sometimes we have to consider, sometimes it is not considered. So what it makes to the students, they will be confused. Okay. So in order to rectify that confusion, again what measures we have to take it, we will see in the coming topic. The rules for determining the numbers of significant figures can be understood from the following examples. Significant figures indicate, as already mentioned, the precision of measurement which depends on the least count of the measuring instrument. So we have measuring instruments like the linear vernier calipers, the screw gauge, not your meter scale. So in physics, as you are a physics student, now meter scale will be only taken for rough measurements. Okay, and so if we are for the experimental values, to determine the precise value of the length, breadth, volume, for everything we have to take the vernier calipers. Sometimes we will take the traveling microscope depending on the type of the experiment. Okay, now a choice of change of different units does not change the number of significant digits or figures in the measurement. So whatever you are taking the units, centimeter, it may be centimeter, it may be meter, it may be millimeter. So every time the number of digits, significant figures, does not change at all. How is that? We will see. For example, the length 2.308 centimeter has 4 significant figures, but in different units. The same value can be written as 0.02308 by meter, because when you divide this by 100, it is in centimeter. You see, 2.308 centimeter it is. So if the teacher says you to convert into meter, how you will do? You will take, or you will divide this number by 100. Okay, so how much you are going to get? 0.02308 meter. Okay, right. In millimeter again, it will be 23.08. That is, you will divide it by 10. So that will be in millimeter. So again, what you are getting? 23.08 millimeter. So here also it is 4, here also it is 4, here also it is 4. So in whichever unit you are taking, and here you see micrometer. Again micrometer, 10 to the power of minus 6 meter. Right? So here also again the number of significant figures does not change at all. Okay. All these numbers have the same number of significant figures or digits, 2308, namely 4. Okay, so now let us see the rules. So these are very, very important rules what you have to follow. All the non-zero digits are significant. So all the non-zero digits are significant. All the zeros between the two non-zero digits are significant. So for example, if it is 2003, here totally there will be 4 significant figures. Okay, so zeros are in between two non-zero numbers. Hence, it has a certain value. It is significant, no matter where the decimal point is located. So, if we take 20.03, so here point is there between these two. So, again, this also 0 has the value. Understood? Now, so here you can see. Now, this has no... if the number is less than 1, the zeros on the right of the decimal point but to the left of the first non-zero digit are not significant. Okay, the underlined zeros are not significant. So this 0, these two zeros are not significant in such numbers. Okay, so the terminal or trailing zeros. So here you see trailing zeros. These are significant. The terminal or trailing zeros in a number without a decimal point are not significant. So, for example, 1200. If you take, these are not significant because they are not lying between the non-zero number. Okay. Now, let us take this one. The trailing zeros in a number with a decimal point are significant. So, the number 3.500 or 0.06900 have 4 significant figures. So, here also it is significant. Here also it is significant. Understood? So, there can be some confusion regarding the trailing zeros. There can be some confusion regarding the trailing zeros. Suppose a length is reported to be 4.700 meter. It is evident that zeros here are meant to convey the precision of the measurement and are therefore significant. So you can see here in bank account. So if you take the passbook and go for entry, do the entry of the passbook, what happens is they will be showing 2500.00. So here 00, that means some few more numbers may be added there, so it has a significant value there. Okay, so there here also in measurements 4.700 meter, it is evident that the zeros here are meant to convey the precision of the measurement and are therefore significant. If these were not, would be superfluous to write them explicitly. The reported measurement would have been simply 4.7 meter. This will be accurate. So therefore there is no addition or subtraction. So what it becomes is this here 00, that means some may be added, precise value. Now suppose we change the units. So 4.700 meter, 470.0 centimeter. So therefore how many units you are changing, it does not change the significant value. Okay, all it has the 4 significant figures. Now to remove such ambiguities, for number greater than 0 without any decimal, the trailing zeros are not significant. For a number with a decimal, the trailing zeros are significant. Okay, so greater than 1, if it is greater than 1 without the decimal number, without the decimal point, the trailing zeros are not significant. But for the numbers with decimal, the trailing zeros are significant. The digit 0 conventionally put on the left of the decimal for number less than 1, like 0.1250, is never significant. However, the zeros at the end, that is this one, the end, so they are significant in the measurement. The multiplying or dividing factors, which are neither rounded numbers nor numbers representing measured values, are exact and have infinite number of significant digits. For example, r equal to d by 2 or s equal to 2 pi r. The factor 2 is an exact number and it can be written as 2.0, 2.00, like this. So it is or 2.000 as required. Similarly, in t equal to t by n, that is time period equal to t by n, where t is the number time taken for n number of oscillations. So t is the time period. So in such rules, so zeros values will be significant. Okay, so now rules for arithmetic operation. So for example, if we take density, how we have to determine the density in such decimal figures: 4.237 upon 2.51. So the answer will be 1.69. Okay, so here in the multiplication or division, the final result should retain as many significant figures as there is a original number with least significant figures. So here the upper value has 4 significant figure and the lower value has the 3 significant figure. So which is the least, we have to take only that after when we get the result. Okay, so how much ever the numbers will be, but what is the least number, that number of digits only we have to take in the result. Okay, fine. Similarly, if the speed of the light is given as 3.00 into 10 to the power of 8 meter per second, 3 significant figure, and 1 year, that is 1 light year, 1 year is equal to 365.25 days. Okay, approximately how much we will take? 365 days, right? So therefore 1 year is equal to 365.25 day has a 3.1557 into 10 to the power of 7 second. So that is 5 significant figures. So seconds will be so much. In seconds, if you consider, it will be so much, and it has how many? 1, 2, 3, 4, 5 significant figures, leaving the multiplier. Okay, here you see 9.47 light year. It is 9.47. So how many significant figures it has? 3. So in addition or subtraction, the final result should return as many decimal places as there is in the number with the least decimal point. So whichever number is the least number, that we have to consider in the result. Decimal place. The final result should therefore be rounded off to 663.8 gram. Similarly, the difference in length can be expressed as 0.307 meter minus 0.304 meter, 0.003 meter, or we can write it in terms of the power 3 into 10 to the power of 3 meter. Okay, so like this we have to take the arithmetic values operations for significant figures. Now let us see the rounding off. What is meant by rounding off? Rounding off is nothing but, you have done in your primary classes also, when we have to round off. So here you see, for example, 2.746. okay, so round off to 3 significant figures, that is 2.75. so it is a print mistake here, 2.75, while the number 1.743 we let us consider. We should omit this 3. If it is asked like round off to 3 significant figure, we should omit the 3 value because it is less than 5. So if the preceding number or the last number is greater than 5, we have to round off to the next value, or if the last number is less than 5, then you should omit it. So that's what they are telling here. The rule by convention is that the preceding digit is raised by 1 if the insignificant digit to be dropped, the underlined digit in this case, is more than 5 and is left unchanged if the later is less than 5. Okay, if it is more than 5, we should add it to the preceding number, or if it is less than 5, then just you should leave it, drop it. But what if the number is 2.745 in which the insignificant digit is 5? Here the convention is that if the preceding digit is even, the insignificant digit is simply dropped. So if here it is 4, it is even, so 5 should be dropped. And if it is odd and the preceding digit is raised by 1, if it was 3, then we can raise it. Okay, 2.74. I don't know why they have written 1.74 only. So it is 2.74. So if we take here, here it is 3, it is a odd number, so we can carry 1 here and we will get 2.74. okay, if it is asked, write the round off to the 3 significant figure, in such case only we should do it, or else just leave it and write only the significant figure. So it will be such type of questions will be asked for only if it is asked, it can be asked for 1 or 2 marks. Significant figures. In any involved or complex multi-step calculation, you should retain in intermediate steps on one digit more than the significant digits and round off to proper significant figures at the end of the calculation. Similarly, a number known to be within many significant figures such as 1.97, so many numbers are there, so they will ask you to round off to certain value, approximate value, then you have to do the same. Okay, I hope you have understood till now, and the rest of it I have done in the part 2 section only. Okay, so errors we will see in the next class, relative error and all, absolute error, so that we will see in the next class. So thank you for joining to my class. So if you want to be a dhurandhar in physics, come and join the Sheetal classes. Okay, bye bye, subscribe to my channel, take care.